Walk into two manufacturing facilities producing the exact same product with identical machinery. In one, the floors are zoned, every tool has a marked location, and aisles are perfectly clear. In the other, inventory pools in the walkways, and workers spend valuable minutes searching for specific components. Over the course of a quarter, their metrics for machine uptime, safety, and defect rates will reliably and predictably diverge. Industrial performance is a direct byproduct of the environment. When an organization standardizes its floor, it codifies its discipline into the physical space. The placement of a wrench or the cleanliness of a workbench serves as a live data point regarding the health of the operation. Any active production environment is subject to natural entropy. Left alone, tools migrate, scrap material accumulates, and undocumented temporary fixes become permanent. This disorder generates process variation, and variation reliably masks critical abnormalities. Countering this entropy requires a permanent, engineered solution. That solution is the 7S framework: sort, set in order, shine, standardize, sustain, safety, and security. 7S requires adherence to a strict hierarchy of operations. Each step creates the necessary conditions for the next. Organizations that skip the sort phase to focus on shine build cleaning routines on top of waste, ensuring the system will collapse under the first sign of production pressure. The intellectual framework for this system originated during Japan's post-war industrial reconstruction. Engineers and managers developing the Toyota production system realized that visual organization was a strict prerequisite for process reliability. Within Toyota, these pillars function as technical safeguards. By stripping the work area of everything but the essentials, engineers force defects and abnormalities to reveal themselves before they enter the assembly stream. Just-in-time manufacturing demands that the right materials arrive in the exact necessary quantity, precisely when needed. Operating with such tight tolerances means you cannot afford hidden errors. The environment must be structured so that any deviation from the standard violently interrupts the visual field. If a workplace is chaotic, an inventory shortage or a leaking machine blends into the background noise. By engineering strict physical order, organizations force operational problems out of hiding. The framework begins with the first pillar: sort. The objective is ruthless elimination. The retention standard is absolute. An item only stays if it is frequently used for the specific work performed in this exact location. If it fails that test, it must be removed. Organizations often resist this step. Operators want to hold on to obsolete tooling because they might need it someday. But excess items are active liabilities. They consume floor space, obstruct access to essential tools, and continuously signal to the team that local standards permit disorder. To enforce the sort tiller objectively, practitioners use the red tag system. During an initial sweep, teams attach a highly visible red tag to any item whose immediate necessity is questionable. These tagged items are moved to a temporary quarantine zone outside the work area. This simple mechanism is highly effective because it separates the act of identifying a questionable item from the final decision of how to dispose of it, entirely preventing decision paralysis on the floor. You cannot accurately measure or organize a workspace while it is cluttered with unnecessary artifacts. Decisive removal is the mandatory first step. With the area cleared, the system moves to the second pillar: set in order. This is applied spatial engineering based on ergonomic frequency. Items used every cycle are positioned within arm's reach in Zone 1. Items used once a shift require a few steps into Zone 2, and specialized tools are centralized off-area. The first rule of this pillar is that every item receives exactly one designated location. If an operator has a choice of where to place a tool, that choice introduces variation and retrieval delays for the next shift. The second rule is that these specific locations must be visually marked. By using shadow boards or floor tape outlines, the physical space itself tells the operator where to return the item. More importantly, an empty, clearly labeled outline instantly alerts anyone walking by that a specific asset is missing. The third rule applies to materials and consumables. Setting them in order means explicitly defining the correct quantity using visual minimum and maximum indicators directly on the storage bins. When set in order is fully implemented, an auditor or a brand new employee can walk into the space and determine within exactly 30 seconds whether anything is missing, misplaced, or overstocked, without asking a single question. Pillar 3, Shine, operates as an inspection protocol rather than a simple cleaning schedule. The goal is to bring the equipment to a state of absolute cleanliness to establish a visible baseline. True Shine requires operators to physically wipe down every surface of their equipment, forcing intimate, tactile familiarity with the machinery. It is through this direct physical contact that an operator discovers a microfracture. When an operator cleans a machine daily, they immediately notice a few drops of hydraulic fluid that weren't there yesterday. They detect abnormal vibrations, loose fasteners, or strange metal chip accumulation patterns long before those early warning signs compound into catastrophic machine failure. Advanced Shine practices take this data and act on it. If an operator spends 10 minutes a day wiping up a coolant puddle, the correct response is not to schedule more cleaning time. The goal is to track the contamination to its source and engineer a permanent fix for the leak. This establishes the dependency logic for the sequence. Standardizing a dirty, degrading process simply locks in the disorder. Shine secures the healthy baseline required for effective documentation. The fourth pillar, Standardize, marks the transition from isolated, event-driven physical activities into permanent, system-driven management practices. A highly motivated team can sort, organize, and inspect an entire work cell in a single weekend. But without Standardize, the heavy traffic of daily operations will erase those gains in a matter of weeks. You have to document the baseline. Standardize mechanically locks the system in place. The team photographs the perfectly organized area and posts that visual standard at the workstation. They explicitly write down who is responsible for each zone, what their specific inspection tasks are, and the exact frequency of those checks. By making correct, explicitly documented, visually obvious, and personally assigned, Standardize ensures that following the system becomes the path of least resistance. The fifth pillar is Sustain. It is the final original step and the hardest to achieve. Sustain dictates the cultural transition, where the standards shift from temporary, enforced compliance into automatic, self-regulating habits. This transition relies almost entirely on consistent leadership behavior. When managers conduct daily Gemba walks and immediately intervene when a visual standard is broken, they prove that the physical environment is an operational priority. As the 5S framework matured globally, practitioners integrated two critical extensions: safety and security. These pillars treat workplace protection as an engineered attribute. System design prevents injury and unauthorized access more reliably than relying on individual caution. To function properly, safety parameters like verifying machine guarding and clear emergency egress must be built directly into the Standardize pillar. The same applies to security checks, like verifying access controls on sensitive materials or data terminals. If you separate safety protocols or security checklists into isolated binders managed by separate departments, they will inevitably be neglected. They must be native elements of the daily 7S audit. The sequence is now complete, and the logic is clear. Order enables insight. By sorting out the waste, setting exact spatial parameters, inspecting through direct contact, and standardizing the results, an organization creates a baseline. And that sustained baseline feeds directly back into continuous improvement. The ultimate value proposition of the 7S framework is that it creates an environment strictly allergic to abnormalities. When tools are out of place, or a machine leaks, or a safety guard is bypassed, the deviation stands out so violently against the clean baseline that immediate correction becomes unavoidable. You cannot build excellent, high-precision processes inside a chaotic environment. By treating the physical state of the workplace as a primary engineering challenge, you build the foundation for total operational control. Fix the environment first.